Today we will discuss about the details of the beta functions. I'll share some details with you. Let's first of all start with the basic definition of the beta function. So the very first thing is the definition of the beta function. Beta function is defined as beta mn is equal to what? This is integration 0 to 1 x raised to m minus 1 1 minus x raised to n minus 1 dx for m greater than 0 and n greater than 0. That is the first point. And what are the different properties of the beta functions are? Beta mn, I can write it as beta nm also. And of course all these proofs are there in the text. Second property is integration 0 to 1 x raised to m 1 minus x raised to n dx. That can be written as beta m plus 1 comma n plus 1. You might have seen the point, the basic definition of beta as x raised to m minus 1 and 1 minus x raised to n minus 1. So naturally x raised to m, here we have m minus 1, here we have m. Naturally this expression, this property number 2, it should have beta m plus 1 comma n plus 1. Next, beta mn, that is also defined as 2 integral of 0 to pi by 2 sine raised to 2m minus 1 theta cos raised to 2n minus 1 theta and d theta, which gives some certain important results. That is integral 0 to pi by 2 sine raised to p theta cos raised to q theta 1 by 2 beta p plus 1 by 2 and q plus 1 by 2. All the proofs with proper substitutions, we can prove all these properties. Another property of beta mn is integral 0 to infinity x raised to m minus 1 1 plus x raised to m plus n dx. Fifth property is beta mn is gamma m, gamma n, gamma m plus n. This is the basic relationship in between the beta function and the gamma function, and this we need while solving the examples. Sixth one is integral 0 to pi by 2 sin raised to p theta cos raised to q theta d theta. That can be written as 1 by 2 beta p plus 1 by 2 comma q plus 1 by 2. That is equal to 1 by 2 gamma p plus 1 by, with the prior property whatever we have studied. With use of that property, it has been written in this way. And this particular example, with use of this property, we can prove that gamma 1 by 2 is equal to root pi, that already we have used in gamma functions previously. The next point is the very important thing is the duplication formula is there in the beta functions. What is that? Gamma m and gamma m plus 1 by 2 is equal to root pi divided by twice m minus 1 gamma twice m. Additional important result over here is gamma p gamma 1 minus p is equal to pi upon sine p pi. Also this has been proved, or this has been proved with this particular integral, that is 0 to infinity x raised to p minus 1 1 by x dx, that is also equal to pi upon sine p pi. With use of all these properties, we are going to solve the equations or solve the sums for beta functions. Let's start with solving the beta functions examples. The first one is integral 0 to infinity x cube 1 minus x root x raised to 5 dx. What our task is just to convert the integration given into the standard beta function. That is only what we have to do over here. Nothing else. Just look at this. It's very simple thing. I am substituting the basic formula for beta function that already we have studied. What was that? X raised to m minus 1 and 1 minus x raised to n minus 1 dx. That was the basic formula. Here, what in bracket what we have is 1 minus root x raised to t. So what we have kept is t is equal to root x. So that gives me t is equal to x raised to half. That gives me x is equal to t square. Further, this will be dt is equal to 1 by 2 x raised to x minus half dx. So dt is 1 upon 2 root x dx. So dt finally what we are interested in value of dx. So it is twice t dt is dx. Further, the limits will also change as x tends to 0. As x tends to 0, t tends to 0, and x tends to 1, t tends to 1. With use of these expressions, with the use of these substitutions, the expression will get converted simply in I is equal to integration 0 to 1 t square. At the place of x we have kept t square raised to 3 1 minus t raised to 5 into 2t dt. At the place of dx we have kept 2t dt. So simply it is getting converted into t raised to 7 1 minus t raised to 5. This is m minus 1. Here we have as 7, so m is equal to 8 and n minus 1 is equal to 5 here we have, and n is equal to 6. So this is beta. This expression or this integral is beta 8 comma 6. Finally we know the relationship between beta and gamma functions. It is gamma 8 gamma 6 upon gamma 14. So the final answer is 1 upon 5148. Let's go to the second sum. It is integration 0 to 1 1 minus x raised to 1 by n raised to m. What I need to substitute is this x raised to 1 by n as t, and that gives me x is equal to t raised to n. So dx is equal to n t raised to n minus 1 dt. Again further I have to change the limits. As x tends to 0, t will tend to 0. X tends to 1, t will tend to 1. Finally it will get converted as, look at this, x raised to 1 by n is to be substituted as t, and dx is to be substituted as n t raised to n minus 1 dt. Finally it will get converted into beta function. So it is beta n comma m plus 1. Here I have t raised to n minus 1 and 1 minus t raised to m. So I can substitute that values, and here n we have taken, n is a constant that we took out, and here is the final answer. Next, the third question is again very important. I is equal to integration minus 1 to 1. It is 1 plus x raised to n m 1 minus x raised to n. So I have substituted x is equal to cos 2 theta because we have the formula with us. 1 plus cos 2 theta is equal to 2 cos square theta. And one more formula I have with us is 1 minus cos 2 theta is equal to 2 sin square theta. So to make use of those two formulas, we have substituted x is equal to cos 2 theta. That gives me dx is equal to minus cos 2 theta derivation is sin 2 theta into 2 d theta. Here I have changed the limits also. As x tends to minus 1, this 2 theta will tend to pi, and that theta will give me pi by 2, and x tends to 1, that gives me 2 theta tends to 0, that gives me theta tends to 0. So these substitutions we have kept in the basic integration form. Example, here this minus sign will change the limits. These two limits are big. Initially the limits were pi by 2 to 0. That will change the limit to 0 to pi by 2, and these substitutions whatever I have explained earlier, it simplifies as cos raised to 2m plus 1 theta and sin raised to 2n plus 1 theta. Already we have this expression with us in the basic definition or basic properties of the beta functions, and with use of those properties we have substituted this expansion, that is beta 2p plus 1 upon 2 and 2q plus 1 upon 2. If you remember, that already has been written over there. So finally the answer is this one. Now the next point is, next sum is integration 0 to 1 dx upon third root of 1 minus x cube, that is to be proved as 2 pi divided by 3 root 3. Again, what is the requirement is t is equal to x cube. So x is equal to t raised to 1 by 3 dx is equal to 1 by 3 t raised to minus 2 by 3. Again the limits have to be changed. X tends to 0, t tends to 0. X tends to 1, t tends to 1. So these values I have substituted in the expression. Again it is getting converted into the beta function. And here m, with the value of m minus 1 is equal to 2 by 3. So m is equal to 1 by 3 and n minus 1 is minus 1 by 3. So it has n is equal to 2 by 3. So it is beta 1 by 3 comma 2 by 3. This is our answer basically. But this is further, it is to be solved as 1 by 3. It is gamma 1 by 3, gamma 2 by 3 upon gamma 1. Addition of these 1 by 3 and 2 by 3. We have one definition with us. That is gamma p, gamma 1 minus p is equal to pi upon sin p pi. With use of that, it is p is 1 by 3 over here. 2 by 3 is 1 minus 1 by 3. So it is pi upon sin pi by 3. Sin pi by 3 is root 3 by 2, and here is the simplification, and here is the answer of the sum. Next is again integration 0 to 8x raised to 8. This sum is very simple and very important. I have multiplied this bracket with x raised to 8, that is x raised to 8 minus x raised to 14 it will be, and x raised to 14 upon 1 plus, of course in denominator we have 24. Here this 8 is equal to 9 minus 1, so I can write it as 9 plus 15 in the denominator at the place of 24. Similarly the second integral, it is x raised to 14 at the place of 24. At the place of 24 we wrote 15 plus 9. At the rate of, at the place of 14 we have kept 15 minus 1. With use of this basic definition again, beta mn is equal to integral 0 to infinity x raised to m minus 1 1 plus x raised to m plus 1 dx is beta mn. With use of that, it is beta 9 comma 15 and beta 15 comma 9. We know that both of these values are same, that gives me 0. Next example is integral 0 to 1 x raised to m minus 1 1 minus x square raised to n minus 1. What I need to substitute over here is x square as t, that is the requirement. So x square is equal to t, again x is equal to t raised to half, dx is equal to half t raised to minus half dt, and the substitutions, that is getting converted into simple beta functions. That is the answer. Next is, this is very important example, and of course look at the substitutions over here. Put your attention to the substitutions. Here x minus a and x b minus x is the expression, and the limits are also from a to b. This x minus a is to be substituted as b minus a into t. So here dx will be what? B minus a into dt. At the same time, if x is tending to a, the lower limit of x is equal to a, this t will become 0. And as x is tending to b, this t will tend to 1. Now why these particular substitutions are over there is, what I want, what the basic definition of the beta function is integration 0 to 1. So to make the limits 0 to 1, we have substituted these expressions. Again, if we substitute over here, so integration 0 to 1 b minus a raised to m, at the place of x minus a it is b minus a raised to m t raised to m, and at the place of this x, what we have is b minus a t plus a. We can derive that value of x from this expression, and into b minus a dt, because dx is equal to b minus a dt. Upon simplification, this expression is again getting converted into beta function, and b minus a raised to m plus n plus 1 beta m plus 1 comma n plus 1. Finally, based on the same above example, we have taken I is equal to integral 3 to 7 x minus 3 raised to 1 by 4 and 7 minus x raised to 1 by 4 dx. So this x minus 3 and again 7 minus 3t, it is self-explanatory example. It is solved as the previous one only, and the final answer is this. You can further simplify this and get the final answer. In case of any doubt, you have to contact on these numbers. This is the basic numbers we have provided over here on the screen. You can note them down and you can contact for any of the your queries, any of your problems. If you have, you can send all those problems either on WhatsApp or directly you can text on these two numbers. Thank you.